Okay, so beta, this was what we did in the last session. We had made a list of the stars. हमने सबसे पहले L difference D को चेक किया and जहाँ कहीं भी L difference D की वैल्यू लेस देन 90 आती है, that star is visible to us. Fortunately, all the 5 stars were visible. फिर हमने चेक की suitability for sight. I told you that star has to be at a altitude greater than 10. So that means L difference D should be less than 80. So L difference D basically gives us the zenith distance. So हमें ये पता चला that 4 stars were suitable for sight. Now this last one, Acrux, was not suitable for sight because of its low altitude. So इससे next step में हमने find out किया angle P of every star. So angle P हमें कैसे मिला? We found the SHA of the star from the table. We have the SHA of our meridian. इन दोनों का difference हमने निकाला. We got the angle P. And when we divide angle P by 15 degrees 2.5, we get the time from or to meridian passage. We compare this time with x meridian limit, and if this time is inside the limit, the star is suitable for a x meridian sight, otherwise no. So this is what we did in the last session. Now we are proceeding further to the next type of question, which is slightly different from this one. So these first 3 types were on a similar pattern. जो आगे के 2 types आ रहे हैं, ये थोड़े से अलग हैं. So let's try to understand them.
Now there may be situations or questions in which we may have to find stars and planets which cross observer's meridian within a given interval of time. For example, this one, in position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing observer's meridian between 1800 hours to 1900 hours ship's time, zone time minus 0800 hours on 21st September 1992. To handle such questions, we need to obtain the SHA of an imaginary star on the observer's meridian, both at the beginning of the given interval.
Okay, beta. So this is the question which we have now, and in this question they are asking us that between 1800 and 1900 find the stars and planets which have crossed the observer's meridian. The DR position is given to us, the date is given to us, the time zone is given to us. Because this is ship's time, we can convert it to GMT. So any doubt in the question, beta?
So second magnitude and brighter का मतलब उससे नीचे जो भी रहेगा ना सर, 1 magnitude मतलब.
Second magnitude and brighter means the magnitude should
greater
be
than 2.
Less than or equal to 2.0.
Oh, that's
Yeah,
second
less than or
magnitude.
equal to, right?
Right.
Greater than 1.
सर जब
ठीक है.
सर जब क्रॉस करेंगे सर उनका LHA 0 हो जाएगा, ऐसे करके निकाल देंगे सर.
नहीं बेटा, ये 1 घंटे का टाइम है. सो हर एक मिनट में LHA तो चेंज होता रहेगा. अभी देखते हैं इसको कैसे करेंगे.
Okay.
To handle such questions, we need to obtain the SHA of an imaginary star on the observer's meridian, both at the beginning of the given interval and at the end of the given interval. So we get 2 SHA values of this imaginary star. One, when it is on the observer's meridian at the commencement of the interval, and second, when it is on the observer's meridian at the end of the interval. We know how to calculate the SHA of imaginary star on the observer's meridian. We can equate the LHA of that imaginary star to 360, and this LHA is equal to LHA Aries plus SHA of the imaginary star. We have already calculated in the first question, and we can repeat that process out here. If the duration of time is not given in the question and it is only AM or PM twilight, then for AM cases, the interval used is between the starting time of the nautical twilight to the starting time of the civil twilight. So that shall become the interval. Commencement of the interval shall be at the onset of nautical twilight, and the ending of the interval shall be at the start or onset of the civil twilight. For PM cases, this interval shall be between end of civil twilight to the end of nautical twilight. We can identify the stars and planets within the SHA range thus obtained, corresponding to the magnitude of stars and planets that is given in the question. Now, all the stars within this range shall be crossing the observer's meridian during the given interval. Whether they shall be visible or not, or whether they shall be suitable for taking sight or not, or whether they shall be suitable for exmeridian observation or not, we know once we get a comprehensive list of all the stars and planets, we can do the further analysis depending on whatever may be expected of us in that particular situation or particular question.
Okay, so let's try to understand the strategy for this question. Now, what we do in these questions, beta, we find out the SHA of an imaginary star which is on the observer's meridian. ये हमने पिछली टाइप्स में भी किया था, बट पिछली टाइप्स में हमें एक ही टाइम दिया गया था, सो हमने उस टाइम के लिए इमेजिनरी स्टार का SHA निकाल दिया. अब हमारे पास दो टाइम है, 1800 एंड 1900 इन दिस क्वेश्चन. तो हम क्या करेंगे, हम 1800 के लिए भी एक SHA निकालेंगे, मीन्स द SHA ऑफ ए स्टार which is on our meridian at 1800 hours. और फिर हम 1900 के लिए भी एक स्टार का SHA निकालेंगे, मीन्स द SHA of a star which is on our meridian at 1900 hours. तो हमारे पास दो SHA की वैल्यू आ जाएंगी. वन इज द SHA of a star जो हमारे मेरिडियन पे है at 1800. Second is the SHA of star which is on our meridian at 1900. So once we get these two values, all the stars having SHA within this range will be crossing our meridian. Let us say एक SHA आपका आता है 170, दूसरा SHA आपका आता है 180. तो 170 वाला स्टार 1800 पे हमारे मेरिडियन पे है, 180 वाला स्टार 1900 पे हमारे मेरिडियन पे है. तो इसके बीच वाले जितने भी स्टार्स होंगे उन्होंने हमारे मेरिडियन को क्रॉस कर लिया है. दिस इज द बेसिक अप्रोच ऑफ द क्वेश्चन. सो दिस इज व्हाट वी आर गोइंग टू डू नाउ. इज दिस क्लियर अप टू हियर बेटा?
Yes, sir.
Okay, let's see
sir.
that now. How do we practically do it?
And planets, we can do the further analysis depending on whatever may be expected us in that particular situation or particular question. So now we're in a position where we can solve this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east. Find the stars and planets of second magnitude and brighter crossing the observer's meridian between 1800 hours to 1900 hours shift mean time. Zone time -8 on 21st September 1992. So we first find out the GMT at the commencement of the required interval and GMT at the end of the required interval. So the starting time, ship's mean time is 21st day, 18 hours. Zone time -8. And we get GMT, longitude east, GMT least, 21, 10, 0, 0, 0, 0. So we get the GMT at the commencement of the interval. Likewise, we calculate the GMT at the end of the interval, 21, 19, 0, 0. On time -8, and we get GMT as 21 day, 11 hours, 0, 0 minutes, 0, 0 seconds. Now we get the LHA Aries for these two GMTs. So at the starting time, GHA Aries for 21 hours, 21 day, 10 hours is so much. increment is 0 because it is 0 minutes 0 second. We get a GHA Aries as 150 degrees 31.9 minutes. We apply observer's longitude to it. Longitude east, GHA least. We add the longitude and we get the LHA at the commencement of the required interval as 271 degrees 46.9 minutes. That is the LHA Aries at the commencement of the interval. We get the LHA Aries at the end of the interval. You can see the values coming up on the slide. You can also check them from your almanac. And we get the LHA Aries at the end of the interval. Now we find out the SHA of the imaginary star on the observer's meridian at the starting of the interval and at the time of the ending of the interval. So for imaginary star on the observer's meridian at the commencement of the interval, LHA star, which is equal to 360 degrees, will be equal to LHA Aries of 271 degrees 46.9 minutes plus SHA star, which gives us the value of SHA star to be 088 degrees 13.1 minutes at the commencement of the required interval. Exactly the same way we can get the SHA of the imaginary star on the observer's meridian at the end of the interval.
So beta, what we have done till now is स्टार्टिंग टाइम के लिए जो स्टार हमारे मेरिडियन पे है उसका SHA भी हमें मिल गया है, एंड एंडिंग टाइम के लिए जो स्टार हमारे मेरिडियन पे है उसका SHA भी हमें मिल गया है. सो नाउ वी नो दैट ऑल द स्टार्स बिटवीन these two SHA values will be crossing our meridian. So it becomes very simple now. We have to go to the table on page 268, find out the stars within this SHA range and list them down.
And we get this value to be 73 degrees 10.6 minutes. We have got SHA of the imaginary star on the observer's meridian at the commencement of the interval and at the end of the interval. So all our stars and planets of interest should have the SHA in this range. So the SHA range that is of interest to us is from 073 degrees 10.6 minutes to 088 degrees 13.1 minutes. We go to the star tables and we find out stars of second magnitude and brighter in this SHA range. And for planets, we'll go to the daily pages of the Nautical Almanac for 21st September. Stars and planets of second magnitude and brighter crossing one observer's meridian between SMT 18 to 19 on 21st September. Stars will be only 2. You can check. We already have learned this, how to figure out these stars in the star tables in the range of SHA. And the stars are Vega and Cos Australis. These are the 2 stars in this SHA range meeting this magnitude requirement as per the question. And when we go to the daily pages of the Nautical Almanac for 21st September 1992, we find there are no planets with SHA in the given range on that day. Therefore, we do not have any planet which is going to cross the observer's meridian in this window. On the other hand, we have 2 stars of magnitudes of second magnitude and brighter, which shall cross this meridian of the observer between 1800 hours to 1900 hours.
Okay, so beta, we have the full procedure now, right from beginning to end of this particular question. Have a good look at it and let me know any doubts coming to your mind.
Sir, stars of magnitude 2 means stars of magnitude greater than 1, no? Greater than 1 magnitude होना चाहिए, sir.
Right, beta. Magnitude 2 means 1.1 to 2.0. Okay, second magnitude. Let me show you. You can take a screenshot of this table.
जी सर, ये देखिए सर, बट ये मैग्नीट्यूड 0.1 है ना सर?
Right.
तो ब्राइटर पूछा है ना, इसलिए सर वो ब्राइटर मतलब उससे मैग्नीट्यूड कम रहेगा ना सर?
बेटा उन्होंने क्वेश्चन में डाला है सेकेंड मैग्नीट्यूड एंड ब्राइटर.
Okay, got it.
Okay, so first
Got it, sir.
magnitudes
Yes.
will also be included in it.
ठीक है सर, समझ आ गया.
Right, third fourth नहीं आएंगे, third fourth fifth and sixth नहीं आएंगे because they will be dimmer, but first magnitude will be included. Okay, और कोई डाउट बेटा?
सर जो पहला क्वेश्चन था उसमें था फर्स्ट एंड सेकंड के बीच में, तो इसमें उसमें ये 2.0 वाला नहीं आएगा ना सर?
नहीं बेटा, अगर उन्होंने सेकेंड मैग्नीट्यूड को क्वेश्चन में इंक्लूड किया है, दे वांट अस टू फाइंड सेकेंड मैग्नीट्यूड स्टार, तो 2.0 उसमें इंक्लूडेड होगा.
ओके सर.
Okay, so let's proceed ahead then.
Now, we have already calculated the stars, whether they are going to be visible or not, whether they are going to be suitable for sight or not, or whether they are going to be suitable for exmeridian limits or method or not. I think we have to execute the respective step further if we have to assess them for any other parameter which we have learned, be it their visibility, be it suitability for sight in general, or be it their suitability for ex-meridian observation. Having found the stars and planets which shall cross the observer's meridian within a given interval, we could similarly be required to find the stars and planets that shall cross the observer's inferior meridian during the given interval.
Okay, now beta we move on to the last type of these numerical. They want us to now find out the stars which are crossing our inferior meridian. हमारे मेरिडियन को क्रॉस करने वाले स्टार नहीं चाहिए, हमारे inferior meridian को क्रॉस करने वाले स्टार चाहिए. So this is the only difference. They are asking the stars crossing the inferior meridian. So let's see how we are going to do it.
Observer's inferior meridian is the meridian which is 180 degree opposite to the observer's own meridian. Say for example, this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing the observer's inferior meridian between 1800 hours to 1900 hours ship's time, zone time -8 hours on 21st September 1992. Now, for such cases, we'll have to obtain the SHA of an imaginary star, which is on the observer's inferior meridian this time. Not on observer's meridian, but on observer's inferior meridian, when at the commencement of the interval and at the end of the interval. The imaginary star on observer's inferior meridian, the LHA, because the imaginary star is on the observer's inferior meridian, so the LHA of the star in this case shall not be 360, but it shall be 180. So the difference lies here. In the earlier case, to find the SHA of the imaginary star, we were equating LHA to 360 degrees. In this case, because the imaginary star is not on the observer's meridian, but on the observer's inferior meridian, so the LHA of the imaginary star shall be equated to 180 degrees. If the duration, like the previous case, is not mentioned in the question, then for AM, the interval shall be between the start of the nautical twilight to the start of civil twilight, and for PM, it shall be the end of the civil twilight to end of the nautical twilight, which has been explained earlier. Identify stars and planets of the required magnitude within the SHA range, thus obtained like the previous case. All stars having SHA within this range will be crossing the observer's inferior meridian during this period. It does not mean that they need to be visible. It does not mean they'll be suitable for sight. But yes, what they would be doing is they would be crossing the observer's inferior meridian. Now, here comes an important change. Out of these stars, only those which are circumpolar will be visible to the observer. Because when the celestial bodies cross the observer's inferior meridian, then they shall be above the observer's rational horizon only if they are circumpolar. Otherwise, they will be below the horizon. So only those stars and planets which happen to be circumpolar shall be visible if we have to ascertain the visibility issue.
Okay, so the only difference in these type of question is that we will have to find the imaginary star on our inferior meridian, and we know that if a star or body is on our inferior meridian, its LHA is 180. So we keep the LHA equal to 180 and we find the SHA of the stars. The rest of the procedure is exactly the same. Now, another important thing in this question to understand that for the visibility, since we are talking of the inferior meridian, L difference D criteria will not be applicable here. What will be applicable is the circumpolar criteria. So to check the visibility or suitability for sight, we will need to check if a star is circumpolar or not. So how will we check that? We know the condition for circumpolar bodies are L and D of the same name, and latitude plus declination should be greater than or equal to 90. So this is what we will do if we want to check whether a star will be visible or not. So shall we go into the working out of the question now?
सर ये टाइम लिमिट समझाना सर एक बार AM PM वाला, वो तो हम वहां से ले लेंगे.
ओके बेटा, अब बेटा इस क्वेश्चन में तो उन्होंने हमें टाइम दे दिया है 1800 to 1900. अगर किसी क्वेश्चन में टाइम ना दिया जाए, वो सिर्फ यही बोल दें क्वेश्चन में, फाइंड द स्टार्स क्रॉसिंग द ऑब्जर्वर्स इंफीरियर मेरिडियन इन द इवनिंग ऑफ 15 जनवरी 1992. सो अब नेचुरली हमें कन्फ्यूज़न आएगा कि भाई हम SHA किस किस टाइम का निकालें. सो फॉर दैट हम क्या करते हैं, हमें पता है कि अगर ये इवनिंग टाइम है, यू रिमेंबर व्हेन वी डिड द ट्वाइलाइट क्वेश्चंस, आई टोल्ड यू इवनिंग में जो हमारा सूटेबल पीरियड होता है वो क्या होता है बेटा, सूटेबल पीरियड इन द इवनिंग?
नॉटिकल ट्वाइलाइट दोनों में सर सूटेबल है. मतलब
एंड ऑफ सिविल टू एंड ऑफ नॉटिकल.
End of civil twilight.
एंड ऑफ सिविल टू एंड ऑफ नॉटिकल इज द सूटेबल पीरियड. सो हम उसी को यूज कर लेते हैं बेटा, हम उसी को यूज कर लेते हैं टू गेट द SHA. एंड अगर ये मॉर्निंग ट्वाइलाइट की बात करें कि मॉर्निंग ट्वाइलाइट में फाइंड द स्टार्स क्रॉसिंग इंफीरियर मेरिडियन, तो हमें पता है कि मॉर्निंग में जो सूटेबल पीरियड होता है वो होता है कमेंसमेंट ऑफ नॉटिकल टू कमेंसमेंट ऑफ सिविल. तो हम वही पीरियड एल्मनैक से पिकअप कर लेते हैं. एल्मनैक में हमें सिविल और नॉटिकल दोनों के टाइम दिए रहते हैं, तो बेसिकली यू पिक अप दोज टाइम्स विच आर गिवन इन द एल्मनैक अंडर सिविल एंड नॉटिकल टू फाइंड आउट द सूटेबल पीरियड and to find out the SHA of the stars. Is it clear now, beta?
Yes, sir.
Okay, let's proceed ahead and see the working now.
A star will be circumpolar only if latitude and declination are same names and at the same time, that is plus, the sum of latitude and declination is greater than or equal to 90. So the out of the stars that you list, only those would be visible which are circumpolar. Now let's solve this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing observer's inferior meridian between 18 to 1900 hours SMT. Zone time -8 hours on 21st September 1992. So first we get the GMT at the commencement of the interval. And you can see the SMT 21 day, 18 day, 10 hours, and we get GMT at the commencement of the interval. We get the GMT at the end of the interval, which comes to 21 day, 11 hours, 00 minutes, 00 second. Now we get LHA Aries for both these GMTs. DHA Aries at commencement time is 150 degrees, 31.9 minutes. We apply the longitude east, GMT east, we add it, and we get LHA Aries as 271 degrees, 46.9 at the commencement of the interval. Likewise, we get LHA Aries at the end of the interval. You can see it on your screens, and LHA Aries comes to 286 degrees, 49.4 minutes. Now we get the SHA of an imaginary star on observer's inferior meridian at the commencement of the interval and at the end of the interval, and same is obtained by equating the LHA of the imaginary star to 180. You can see here LHA of the imaginary star is equal to 180, LHA Aries is 271, and putting these values, we get the SHA of the star as 268 degrees, 13.1 minutes. Likewise, we get the SHA of imaginary star on the observer's inferior meridian at the end of the interval, and we put the values, and we get the value of SHA as 253 degrees, 10.6 minutes. So now we have obtained the range of SHA in which we have to find the stars and planets of the required magnitude. The SHA range of interest to us is from 253 degrees, 10.6 minutes to 268 degrees, 13.1 minutes. We go to the star tables, look for stars in this range with magnitude of 2 and brighter, and we get the following stars. We get Adhara, we get Sirius, we get Elena, we get Canopus, we get Mirzam. So these are the 5 stars that we get, which have the SHAs. You can see they are in this range, and their magnitude you can see here. They are of magnitude 2 and brighter. So these are the stars which shall cross the observer's meridian between 1800 hours to 1900 hours ship time on 21st September for an observer in position 40 degrees, 10 minutes north, 121 degrees, 15 minutes east. Now we go to the daily pages of the Nautical Almanac for 21st September to see if any of the planets fall in this range of SHA. And we find that Mars has a SHA of 264 degrees, 06.2 minutes, which is in this range. So Mars would also be crossing the observer's inferior meridian in the given window. Now, where do we get this SHA of Mars from? Where do we get the declination of Mars from? Where do we get the magnitude of this planet from? Let's look at these pages from Nautical Almanac. Now, the left page of the Nautical Almanac, the right bottom corner, we have the SHAs of the planets. And it is from here that we checked the SHA, and we found that Mars SHA was within the limits of the SHA that we were checking for. Now, if we go to the same table on top, here against Mars, we find its magnitude, it's -0.4. So this is from where we picked up the magnitude of Mars. This is the column for declination of Mars. So the SHA of the Mars was seen from here, its magnitude out from here, and declination from here.
So beta, we have the complete working of the question. You can take a screenshot of this particular screen and keep it with you, and you can try out this question actually right from beginning to end. The entire working is here on this single page.